Here are my answers to the pre-lab questions. For number 1, the 2000 in delay microseconds 2000 stands for 2000 microseconds. For number 2, the difference between analog write and digital write is that analog write writes a signal to a PWM pin and can be assigned a duty cycle value of 0 to 255, while digital write writes a signal to a digital pin, including PWM, and it is assigned low or high. For number 3, all the pins that can be used for analog write are 3, 5, 6, 9, 10, and 11 on the Arduino Uno. But for digital write, it's 2 to 13. For number 4, the call for analog write is on a scale from 0 to 255. For number 5, the Arduino's PWM frequency is 490 Hz on most of the pins, but pin 5 and 6 are 980 Hz. Here's blink, where the LED will be set to high for 1 second and then set to low for another second, and repeat. Here we have an LED blinking at 40 milliseconds on, 40 milliseconds off. The fastest that I could see the LED blink at was at 13 milliseconds on, 13 milliseconds off, which falls at around 40 frames per second, which is in the range of 30 to 60 frames per second, which is considered the fastest an eye could see. Here's Arduino running the fade sample code. As the duty cycle increases, the LED gets brighter until it reaches the maximum brightness, which is when the code tells it to reverse and fade back out. Here's the LED slowly fading from dark to bright and from bright to dark. Here's the LED fading from dark to bright and bright to dark at a medium speed. Here's an LED fading from dark to bright and bright to dark at a fast speed. One thing that I noticed is that using the built-in PWM is much easier than having to manually code a digital pin to make the fade happen. Here's my own project where I created a die that could roll a random number 1 to 5. It's currently off, but if you use this to turn it on, it rolls a random number, which was a 3. Turn it back off, turn it back on, a 5. Turn it back off, turn it back on, a 4. And you can just keep rolling new numbers over and over again.